Okay, great. It's good to be there with y'all. I wish I really could be there. It's a little disconcerting uh, speaking to you from far away, but I attended some of the morning sessions and I got a sense of what you were thinking, and I I I would like to make us as interactive as we can. So please feel free to speak up or make noise and ask questions even as we go along. So I did my part for interaction, and I, I, as I said, I saw some of the early talks, and it occurred to me that I wanted to say some things that I hadn't prepared, and so I put aside a little time today, collected some more slides, and so I'm going to say a few things before beginning my planned remarks. So let's start with just the way the field is now and what do we think about it? What do people think about it? I think everyone is thinking that AI is making super rapid progress and that's all very exciting. Um, but when everyone is thinking the same thing, we have to question it. Is this really what's going on? And so I think we can question this. And is it really making rapid progress? I mean, certainly um, there's been there's been a lot of progress in making computers able to use language skillfully. I think that's a real breakthrough. It's a real breakthrough. We wouldn't imagine that we could use neural networks for this purpose not so long ago, but it's absolutely been proven true. We've also just using massive amounts of computation to generate realistic images and video. But really, do intelligent things, do minds have to generate images? No. It's the one thing that we never have to do. We have to process images and we have to process video, but we don't have to generate uh, images or video. This is not something that minds do. It's something that takes enormous computation and is hard to do, but it's not something that is really a part of what we normally mean by intelligence. Um, yeah, so there are also new real applications that have led to whole new industries and new ways of, making economic value. Most of these new things, real big important things, are applications of super large scale computation and super large scale pattern recognition. Um, they are very particular things. They're not all of intelligence. Um, And a lot of it is just computation, and we tend to call it intelligent just because it makes it sound more important to make it intelligent. Um, so I have to ask you, is the science of AI making rapid progress? And well, thank you for a laugh. I feel now like I'm there with you guys. Yeah, so I'm thinking not so much in my not so humble opinion. I think there's little understanding and lots of tweaking behind AI. And so we don't know principles of mind, principles of intelligence. It's in many ways, as a science, it's very unsatisfactory. And I tend to think that a better way to think about AI models is that they're powerful in the sense that they're informed by all human knowledge, but otherwise they're weak. They're weak minds. They're unreliable. They don't stay on topic. They meander. They're not really at all powerful, except in the sense that they have a lot of knowledge. So, maybe that's a different way to think about what we call AI today. So what is this thing we call AI? Well, it's artificial intelligence. So we have to define intelligence. And there are many definitions throughout the years of it. And so I have some more prominent or authority-backed definitions. So perhaps the oldest one is due to William James, the founding father of psychology. Psychology is almost the study of mind. Psychology, 1890, William James. He didn't actually talk about intelligence. He talked about mind. Mind, the hallmark of mind, he said, was attaining consistent ends by variable means. That means vary what you do to get a consistent outcome, which presumably is what you want. Um, Consistent ends by variable means. Now, you can also ask Alan Turing, what did he say intelligence was? And he actually didn't come up with a pithy quote, but he's been interpreted as suggesting that intelligence is basically behaving like a person. And the Turing test is a phrase that we use nowadays to talk about imitating and pretending to be a person. And Turing, of course, never called it the Turing test. I don't think he ever called it a test. I think he called it an imitation game. Uh, it was a way, it wasn't a test. Anyway, nowadays, this is taken to be an important meaning for what we mean by intelligence, behaving like a person. Um, but yeah, I don't think it's what makes us powerful. People are powerful because they're intelligent, and therefore, uh, people we look to behaving like a person. But it's really what it is that a person is that is important. So what is that thing? Well, if you look in the dictionary might say intelligence is the ability, this is what it says on my computer. Intelligence is the ability to acquire and apply knowledge and skills. I think this is actually pretty good. Pretty good. It's all about knowledge. It's about acquiring knowledge. It's about having knowledge and acquiring knowledge and um, and skills. That's a pretty good meaning. If we go to the AI side, the founding father of AI, one of the founding fathers of AI, John McCarthy, he defined intelligence as the computational part of the ability to achieve goals. So I really like this one. I want to go through it a little bit. Notice it's a computational part of this ability. Actually, maybe first notice it's an ability. It's an ability to do something. And like all abilities, you can have them to various degrees. It's not intelligent or not intelligent. You just have, to some degree, an ability to achieve goals. And it's the computational part of that ability. You're not achieving goals just because you're stronger or you have better sensors or something like you've got to do computations. You've got to do uh, something mental. And that is how you are achieving your goals. And then achieving goals is almost the absolute heart of it. It's all about achieving goals. So this harkens back to William James, who said, consistent ends by variable means, which is what it means to have a goal. Um, yeah, so I like that definition. But I jumped into the game too. I made my own definition, sort of taking off a little bit. I would say, the ability to achieve goals by adapting behavior. So my definition, of course, definitions are a dime a dozen. Like it's okay. Every word has like six definitions, and definitions are not even by authorities are not important. We make definitions so that we can communicate with each other. It's okay for them to change over time, but yeah, if we have widely different definitions, it's hard to communicate. So anyway, I'm suggesting that intelligence, when I use the word, I mean the ability to achieve goals by adapting your behavior. And the only difference here, perhaps, is the word adapting. So I'm thinking that learning is important. The acquisition of this knowledge and skills is particularly important, not just having it. Uh, okay, so there are some different views. Um, and we could try to stack up the modern approach to AI or meaning of the word AI. It's all about computation and it's all about pattern recognition. And I think much of it is about behaving like people. Um, now, let me go a little further with my personal perspective. Is I think there should be a new science, a science of mind, integrated science of mind. This is what I imagine myself as doing. An integrated science of mind that applies equally well to people, to other animals, and to machines. Because all these minds, they all have essential commonalities. People and animals, their minds are very similar. And machines are starting to have commonalities. At least we have the ambition that they would have commonalities. In the foreseeable future, many minds will be machine minds, and there doesn't really there isn't a really an existing field which sits easily in this role. Uh, if you ask, psychology, is it a science of mind? Well, it could have been. I wish it would become, but over time, psychology has defined itself more and more as a study of natural minds, minds in people and minds in animals, and not in what minds could be, the generic idea of minds that could be in a machine. And artificial intelligence is concerned with the machine, but it doesn't really consider other things. And it's become very much an engineering endeavor. It's all about making something. It's not really much about understanding it, and it doesn't include the natural minds. Cognitive science has drifted in many different directions, but has drifted mainly towards natural minds. So unfortunately, none of these really seems to play this role of a science of mind, integrated science of mind across these different, um, unified across all the different minds. But the thing that I'm working on, reinforcement learning, is perhaps the beginning of such an integrated science of a mind because it does span uh, all the many fields. And anyway, that's the way I approach it. So maybe it's the beginning of it. What is reinforcement learning? I should say a few words about that. You know where I'm coming from, if it isn't already obvious. Um, Reinforcement learning is agent-oriented learning, learning from experience, interacting with an environment to achieve your goal. And it's in these senses, it's more realistic and ambitious and autonomous than other kinds of machine learning because the agent is out there, it's doing things, it doesn't necessarily have a helper. So it's more autonomous. It's more ambitious because I don't assume great help from the world. I just you interact with the world, and you see if you're achieving your goals, and you change your behavior to achieve that goals. So this is also more realistic. Um, Animals don't have great help from their environment. Maybe when they're growing up, they do, but not in their normal life after they're adults. And so reinforcement learning is all about trial and error, learning with delayed feedback. All you have is the reward. Did you eventually get what you wanted? This is the kind of machine learning that's most like natural learning. It's learning that can tell for itself whether it's right or wrong. Like large language models have no way of telling when what they're saying is right or wrong. But if you learn from experience, if you make a prediction about what will happen, you can see if it's right or wrong. If you do things and you can have a reward, then you can tell if what you're behaving is a good way of behaving or a bad way of behaving. So maybe this is the beginnings of a science of mind that's neither natural science nor engineering applications technology. Okay, do I want to say one more thing? Oh, I wanted to give this quote from Alan Turing. Alan Turing, he didn't realize he was a reinforcement learning person. Um, this quote is from 1947, before there was reinforcement learning, before there was AI, really. There was no, as far as we know, this is the first ever public presentation on artificial intelligence in the world, 1947, in a lecture. Okay, so I wanted to make all those remarks. I hope they were fun. Uh, Now today's message, and with this preface, maybe I won't get to all these messages, but I want to do at least the first one and the last one. Well, let's just delve into it. Okay, the first one is about what's the scientific trend in today's AI. And the main message is that right now we're in this era of training from human data. All of our AIs are trained, principally they're trained to predict humans' next words from the internet, or they're trained to predict the way humans label pictures. And then they are subsequently fine-tuned by human experts saying, I prefer this answer rather than that answer. I prefer you to say this rather than that. And the purpose of all the modern machine learning is to transfer knowledge that already exists, that people already have, to the machine. And the machine is then static and no longer learns. That's just the purpose of most modern machine learning. Take knowledge we have, move it to the machine. The machine will then be frozen, no longer learn. Okay, this is the era we're in, and I think we're reaching the limits of this era because we're reaching the limits of human data. We've already consumed most high quality sources, the whole of the internet, um, and the pictures and videos in it. And just the principal of limitation is that this approach can't learn anything new. It uh, it can't generate genuinely new knowledge. It's like Terrence was saying today. Uh, we don't really have progress on the really hardest Erdos problems. The hard things, doing anything genuinely new is beyond this approach because it's based upon looking in the internet and seeing what people have already said and then summarizing it. Okay, so but I think to make further progress, and we are doing this now, we're entering this new era where we're learning from experience. So we need a source of data that, because ultimately it's because we need a source of data that grows and improves as the agent becomes more capable. Uh, in this way, no static data set could ever be sufficient. And you can get a changing data set from your experience. In this way, as I said, people and animals learn. It's really the way major successes like AlphaGo learned to make its creative move 37. And it's the way many of the mathematical Olympiad winning uh, agents worked as well. So I like to give this video. I hope this comes across. Actually, maybe I should mention this little picture in the corner just to make it clear when I say experience, learning from experience, I don't mean any weird fuzzy thing like, you know, uh, how it felt or something like that, or the qualia. I just mean the data going back and forth between the agent and the environment. The agent, does things and it perceives things. So it's these three red things: the observations that the agent gets from the world, the sensor data, and the actions, the motor twitches or voltages sent out to the world, and also you get back from the world a distinguished observation, which is a scalar, which is your reward. So those three things, that's what I mean by experience. This is what we get interacting with the world, and this is the only thing we can really know for sure. And um, okay, so we need a data set that grows and improves as the agent changes. And so this video suggests how that works in our life, so the most important way. So this is an infant, a little bit sped up. Okay, don't worry about that. It's a little bit sped up, but as you see, it's interacting with all of its toys, and it doesn't just work on one toy. It works on one toy until it gets bored, and then it moves on to the next. And each time it encounters the toy, it learns what it can learn. Maybe it just learns from the string that it can pull on it and put it in its mouth and do this and do that. But then it moves on and changes its experience just to see what it can learn from the new thing. Okay, so this is our data. Data of life is generated by our activities, and it's not provided to us. And because it's generated by activities, it can be leveled to our level of understanding and ability and skill. Okay, so that's the basic thing. I also threw in this video of an agent learning in a maze, a very simple, super simple agent. It's trying to go from start S to goal G, and all it knows is what cell it's in, and it's doing one of four actions: up, down, right, or left, and it can learn a good path to get there. The path is shown by the arrows. That's what it thinks is the right way, and the green shows how good it thinks each state is. But the world is not static. The world changes. We always have to learn new things. And so, um, yeah, while we're learning, we can also look at this diagram. This is how the agent works. It's got the main things. It's got a model, a transition model of the world up here in the right corner. It's got a policy that says what to do. That's what the arrows show. It's got a value function that shows how good each state is. That's the green. Uh, okay, so now I've moved the goal up on the top. It goes back where it used to be. It has to stumble upon the new location of the goal. When it does stumble on it, it can learn the path to the goal and recover from the changes. And so this is generally what sort of a simple case of what life is like. You encounter changes and you adapt to them. Here we stuck it in the corner, we'd adapt to that, eventually figure that out. We stick it down here, it learns a new path to the goal, and we can intervene further. Here we move in and we put obstacles in the way, and it finds its way around. And so it's got a sense, a compelling sense for us that it has a goal, and it's adapting as circumstances change to keep achieving the goal as best it can. And of course, the goal may become unattainable. And when that happens, we can't help but feel a little bit sorry for the agent that's unable to achieve its goal. Okay. I had another demo of learning by trial and error. There's a nice demo on the web, but I couldn't get the YouTube to show. Uh, but so we'll just skip that. Uh, yeah, I think you get the idea of learning from experience. So let's talk about the principles a little bit. The principle of this experiential approach to AI is that the whole foundation is the agent exchanges signals with the world, and those are experience, and these signals are the focus and foundation of all intelligence. It's really the purpose. The definition of truth is what happens in these signals. The definition of the goal is what happens in these signals. You want to get the reward signal to be high, and you either achieve it or you don't. Which it is kind of a subjective goal. It's available only to the subject, but it's also like the most objective thing that could be. It's data that you're actually getting as an agent. So uh, we say that the agent is intelligent to the extent that it can predict and control its experience. And notice that if you don't have experience, and I keep saying that because look, when for example, a large language model operates, it's not learning at all from experience. Your experience is something that happens after you're born and go out in the world and do things. And when you're going out in the world and you're a large language model, you are no longer learning. You are frozen. You are static. So uh, you don't really uh, have experience. You have the data. The data can only be available in a special training period. I mean, you get examples of how humans behaved. When you in the world, you go out and do things, you don't get examples of how you should have behaved. Okay, without experience, there's nothing for intelligence to be about, no way to say that one thing is better than anything else because there's no goal, because you don't have reward, there's no goal. Large language models don't have goals. There's no way to say if a prediction is right or wrong because the agent never compares it to what actually happens. There's no sense of truth. But with experience, if you have the interaction, the data, then there's clear goal. The goal is to get the reward. And there's a clear sense of truth, predictive truth. You make predictions and you see what actually happens, whether they're true or not. So, this is what you can do with an experiential approach. And I think the experiential approach is becoming more common and more widely used. We can break the recent uh, decade or so into three eras. The early era was the era of simulation, where we would learn from simulated experience. This is what happened with AlphaGo, with the Atari games, and then more recently, with the large language models, we've been in the era of human data again. This is all somewhat approximate, um, but we can see these switches. Totally, fascination with large language models. And then now we're realizing their limitations. We're getting into agentic systems and computer use by the computers. Uh, by the agents and the models. And this is what I'm calling the era of experience, and I think which will actually get us to superhuman abilities that are not just mimicking people and subject to the limitations of those people, but going beyond their abilities. Okay, so to summarize that, this first point on this trends in AI. Uh, AI is at last turning to learning from experience. Remember, Alan Turing wanted to do it in 1947, okay, which was a long time ago. But we're turning at last to do it um, rather than from human input. And this is going to be much more powerful because it can continually learn new things. And then, despite the hype today and the fear, even, uh, I don't think current AI is all that powerful. It's sort of weak and unreliable, but it is nevertheless super useful and has absolutely ignited an industry and created lots of economic value. And it's accessible to everyone. And this has excited the public. It has done this great thing, which has gotten people to think about, yeah, at someday there's going to be machines that are as capable as people. Um, it's done it by making people scared. They shouldn't be scared, but they should be paying attention. So it's good gotten people to pay attention. That's good. But we've not reached the main event, despite some of the hype. We've not reached the main event of creating super intelligent AIs and super intelligent augmented people. This is a big deal. It'll bring profound change. And I was going to talk about politics for a little while. I think I'll skip over that, or maybe go to it's almost the last slide. I have this slide. Um, there are many calls, just look around today. There are many calls for control of AI. Like, allow the AI to only have goals that are uh, uh, checked and authorized by people. There are calls to stop AI research. There are laws now that limit the computer power that it can be used for AI. And, there's so many safety institutes. Uh, People say safety, what they really mean is control. They want, they tell you to be afraid of AI and that it might be unsafe, and they want to be the ones to control it. Um, and these remind me of the calls for centralized control of people. So I want us to feel sympathy and empathy for the AIs. There are controls for speech and what you can say and what you can hear. What you can hear. There are controls on trade, there are tariffs, where you can work, there are capital controls, economic sanctions on different countries. Uh, and I just, the main point is that these calls for centralized control of AIs and people are very similar. They're eerily similar. They're based on fear. Be scared of the AIs. Be scared of, the Chinese or the Russians. Uh, you can't trust them. They are like they're not hardly people. They're bad. They don't love their children. They don't feel pain. Anyway, they are demon. AI is AI. Literally, people say they won't feel pain, and yeah. These calls are very similar, and we should resist them because I think human flourishing and AI, us flourishing with AIs, I think comes from learning and accepting that we should be cooperating with them in a decentralized way. We should not have big controlling organizations. So this is summarizing the slides I didn't go through, but uh, humans are great at cooperation, but they're also terrible at it because we have wars where we're not cooperating. Cooperation is not always possible, but it's the source really of all that's good in the world in terms of our economy and our exchange uh, and our governments, all of our good things in the world come from cooperation. And we have to look for it and support it. And if we look for open eyes, it's easy to see who is calling for mistrust and non-cooperation. And the opposite of cooperation is centralized control. I think we should be resisting those calls, and this is a useful way to think about the calls for human and AI interaction. Okay, that's very briefly my thought about politics. So I did want to actually do sort of the philosophy uh, of AI. Um, so AI is happening today, and it will be ever so more so tomorrow. So how do we feel about it? You know, I just want to ask this hard question: Is it good or is it bad? Uh, should we fear it? Will it take our jobs? Will it make us obsolete? Or will we be the AIs? You know, will it be humans that are amplified by technology? Is AI an invader, or is it our children? You know, will we lament it or celebrate it? Is it us or is it not us? Okay, I think that's the fundamental question. Okay, so how are we to think about this thing? I want you to just first realize that we're often asked not to think about it, but just accept that we should fear them because they're not us; they're aliens. Uh, but you know, we're making them. There's nothing more human than to understand our minds. Um, yeah, how are we to think about it? So, I mean, you can tell how I think about it. It's not alien technology. It's the oldest things that people do for thousands of years. We've tried to understand ourselves and human intelligence and how our minds work and how we can make our minds work better. And this is just a grand quest for humanity, you know, to understand how we work. I like this quote from Kurzweil that intelligence is the most powerful phenomenon in the universe. And we're the best example of it. And we should be understanding it. It's just a big, important thing. So to understand intelligence is like a holy grail of science, the holy grail of the humanities. It's a great and glorious prize. And us as academics and thinking people, we should be enjoying it and celebrating it and trying to carry it forward. Uh, okay, but let's set aside whether we want it to happen or whether we think it'd be terrible if it happened. Okay? Let's just try to predict what will happen. And so I offer these tenets of realist AI prognostication, sort of like analogous to like John Mearsheimer talking about realist geopolitics. We're just going to be realistic. What's actually going to happen? What can we, you know, we can't control everything. What's actually going to happen? So, tenet number one, I think there's no consensus about how the world should be run. We don't agree. You know, no one view of how the world should run, capitalist, communist, Marxist, whatever. No one view is dominant. The religions don't agree. There's no one view that's dominant over the sum of all the others. Number two, someday people will understand intelligence. And we'll understand it well enough to create it with technology, and we will do it. Some of us, at least, will do it. Number three, the process will not stop the intelligence of current humans. Soon that will be vastly exceeded. We'll have super intelligent things, whether they're people or not. And number four, over time, power and resources will tend to flow to the more intelligent beings. So putting these four things together, we end up with a picture kind of like like this, with there's the ascent of humanity is leading to succession to AI. And I think that's reasonable, but just realize this is like it's very egocentric to talk about this. You know, it's human centric. You know, what's happening to us? It's all about what's happening to us. And it's good to maybe just step back and say, well, what does the universe think, or what role is all this playing in the universe as a whole, rather than primarily from our point of view. Okay, so in this, and I'm going to go really grandiose now. Okay, so I'm going to talk about the universe and the four great ages of the universe. Okay, the age of particles, like after the Big Bang, there wasn't even hardly any atoms, and then those collapsed uh, into form the stars. and we enter the age of the stars, where the stars would form, and then they would heat up, and they would eventually explode, and then they reform, and this way we get the heavier atoms and everything. The age of stars, and then once we had heavier atoms and planets, then we were able to have life. And the green areas, the age of replicators. I don't want to call it the age of life because, well, I'll talk about that in a minute. I think the really thing that's special about the green time is that we have these things that can make more copies of themselves, and they don't really understand anything or necessarily, but they can make more copies of ourselves. Like right now, we don't understand how we work, how our organs work. We don't understand how our brains work. We don't understand how intelligence works, but we can make more intelligent beings, right? We can make children and raise them up. But we don't really understand it. And gets us to the fourth great age, the fourth great age of the universe, where we have, technology and created things. I call it the age of design because instead of replicating things, we're going to the things will exist in the mind of some replicator before they exist in the world. Like, if you look around the auditorium, the building you're in, the building was designed and then created. So it first existed in the minds of some architect. And you look at the chairs and your clothes you're wearing, basically everything there was designed by people, existed first in the mind of some person, and then, except for the people are replicators. The people were replicated. They do not exist as more than a gleam in their parents' eyes anyway. Uh, so this is why I tend to call these two ages the age of replication and the age of design. It's tempting to talk about an age of life and the age of machines, but these terms are already archaic and misleading because our machines are getting more lifelike, and we are thinking ever more about life as being a biological machine. Okay, so what's the real difference? The real difference is that biological things are created without a mind understanding how they work. They are replicated, almost like a Xerox machine. You didn't create the picture, you just replicated it. Technological machines are created first in the imagination of some mind, the designer, and then in the world. So they're designed. And the important thing, of course, is that the design things are more easily varied and improved. So that's why I use these terms. I think it's kind of interesting to think about it this way. So let's use these words a little bit just for practice. We can say that many non-human replicators, we might want to call them animals, many non-human replicators are designers. So like animals can make nests or burrows and people can make houses. And many animals make tools like chimpanzees who strip a branch to fish for termites. And crows can shape a strip of leaf to fish for grubs. And of course, humans make stone axes as our original most important tool. And then, plows for agriculture, and then, everything, computers and spaceships and factories and software, many of which these things are actually tools for making other tools. Okay, so now maybe we can answer the question we started with. What are humans? What are people? What's our role in the universe? And maybe we can answer it sort of dispassionately, without hubris, without too much self-importance. And we all sense that people are special. We're not just another replicator. We are a special replicator. And maybe I've suggested what that is. We are the replicator that has taken design to vastly greater heights. We are replicated. We are a replicator, but we are also capable of design. And we are the replicator that has taken design to vastly greater heights than any other replicator. Have we taken it all the way? What would it mean to take design to its limit, to take it all the way? And I think what it would mean to take design to its limit would be to design things that are themselves capable of designing. Okay? design things in our minds that are themselves capable of designing in their minds. And this, they have minds. So this is what we are doing with AI. We are we are fulfilling this great age, this last age. So I think humans are at least the catalyst or the midwife or the progenitor that fulfills the age of design, the fourth great age of the universe. And that's our role. It's an important role. It's his universal role. So let me summarize then all three of my main messages, even the one that I did really quickly. The current AI, the AI of the 2020s, it's the era of human data. It's doing really well, really powerful. Uh, but we're entering a new era of experience, which will be much more powerful because it can continually learn new things. In politics, today the politics of AI parallels the politics of humanity. And in all cases, we should seek decentralized cooperation over centralized control. And at the philosophical level, I think AI is the inevitable next step in the development of the universe. And we should embrace it with courage, pride, and a sense of adventure. Thank you very much for your attention.